Hi, everybody. Karen Roby here for ZDNet. We're talking about edge computing today with Scott Fulton. Scott's here with us to talk about this. And this is a pretty broad topic, of course, but the future of edge is something that we can dissect a little bit here today, Scott. So why don't you just start with us, in terms of companies, who do you think is best suited to provide edge computing services that, can compete against the public cloud? And are there names that we may recognize?
Hi, Karen. Good to be with you. You will recognize some of the names in this field. Hitachi has a division of Vantara that is looking to provide computing power. Seagate and Western Digital are both highly invested in edge computing with the idea of being able to distribute storage closer to where these applications are going to be run. By these applications, I'm talking about things like analytics, artificial intelligence, things that need to be geographically distributed closer to where data is being collected in the enterprise or in enterprise applications, especially in fields like logistics. Because shuttling all that data to a public cloud or collecting it locally in one's own data center or co-location facility is becoming too expensive. The movement of data is a huge money generator. So we're trying to minimize that. Now you've heard that phrase, the edge, be used for a number of different definitions. Marketing likes to kind of take advantage of that because edge sounds edgy. So the big question, I suppose, would be, what am I talking about? And in this context, edge computing is an effort to move the processing capability, the processing capacity, closer to where it can be used most effectively, where it can be used most quickly to minimize latency and to reduce cost. Now, if we were talking about electricity, theoretically, it would be wonderful if we could take electric generators, make them smaller, and distribute these small electric generators all over the country. It would cost less to distribute the energy if we could do that. But it's not really feasible because electric generators, first of all, you can't really control them remotely, not even at a medium scale. And second, there's a real estate problem. People don't want an electric generator in their neighborhood. So that's why we have such big generators right now. In terms of computing power, you can distribute it in geographically if you have the right, what a fellow in the business would call a real estate land grab. If you get there's just exactly the right deal to put small data centers in opportune locations. And right now, that opportune location is right next to cellular towers, to transmitters, base stations that are being used for 4G and the upcoming 5G. That right now is the edge we refer to when we talk about edge computing.
Yeah, and it is, Scott, I'm glad you said that. It is, as I mentioned, a broad topic, or it's used in so many different ways, I feel like. And you're right, you do, as a kind of a marketing thing, that edge, it does sound edgy. It does grab your attention, to say the least. So, in terms of examples that you could talk about here a little bit about edge computing services for, the kind of enterprises that would gladly pay a premium to have them on the edge rather than the cloud.
Well, let's say that your business collects a lot of data from field operations, from sensors that are placed in remote locations, from branch offices that are conducting business with customers in remote locations, and you have hundreds of those. Right now, one of the biggest expenses that an enterprise incurs is funneling the data into these massive data stores. And you hear about big data. We've talked about it here. I published a lot about that on ZDNet. Big data is a big industry because it can generate revenue from simply the transfer of the data as well as the storage. And those big data stores are these public cloud hyperscale data centers. They're in these co-location facilities, Reston, Virginia is a colossal data market because there's a lot of data being moved. It's not just the storage of it, it's the movement of it. So an edge application could say, well, what if you only gather the data that's being collected in a couple of these branch locations, maybe just one of them, and move the analytics processing capability right next door so that you're not storing as much. You're processing it in a smaller facility that's easier to maintain and that's easier to cool, because cooling is a colossal cost in a data center. If you're making a big data center, it costs a lot to cool it. You make it smaller, you're not just chopping up the cooling expense, you're reducing it, oftentimes by as much as 40%, as a number of the studies are showing. When you can process an analytics thing, when you can extrapolate information about small areas of data, where is this trend line going? How much of this do we see? And in artificial intelligence applications, do these things form a pattern? Does this movement in the woods constitute some guy who's trying to break into your building? It's going to be much more valuable to have the processor close to where it is. It's going to take minutes, if not hours, even in these microsecond by microsecond operations, to transfer data into the public cloud and back out of it.
And Scott, you mentioned just a few minutes ago talking about, with 5G. So what happens to 5G wireless if it's, say, this new revenue channel from edge computing doesn't get itself sorted out here soon?
5G wireless, one of the big promises of that is to try to branch out telecommunications companies' areas of revenue to make money from new and different things. One of the things we've talked about here is from home and small business internet service, and also being able to compete against Comcast and Charter Communications with home television with 4K broadband. But the other major point is to get telecommunications companies the possibility of competing, even if in a limited way, with Amazon AWS, with Microsoft Azure, with Google Cloud Platform in cloud computing services. By taking applications that people are normally using the cloud for, that enterprises are using the big public cloud for, moving them out of the hyperscale facilities and into smaller data centers. The reason that's a 5G thing is because that type of connectivity requires fiber optics, requires wire. It's wild to say how much of that 5G wireless requires an actual optical wire cable, but it will require orders of magnitude more cable than we've had for 4G. But we can leverage the 5G and help to pay for all the costs of digging those new lines and connecting all those new towers if we could use it for something a lot more practical, like having a little cloud service that's distributed in various places across the country. The map I've got behind me shows an example of one of these things actually happening right now. There's an organization that calls itself the Kinetic Edge Alliance. It was formed by a group called Vapor.io, which I talk about a lot in ZDNet. Vapor is one of the catalysts behind the edge computing movement. And these little V's that you see here that are circling Austin are an encampment of edge computing stations, mini or micro data centers that are connected to one another, the red lines, by fiber optics. And they're using the fiber optics for backhaul, for getting that data from each of these other 5 locations up to the one that's closest to wherever the customer is. And so this is making it so that you can have cloud-like services covering hundreds, perhaps a few thousand customers all over Austin, Texas.
Okay, and Scott, when you talk about the public cloud, the computing market changing if edge computing becomes a successful alternative. So it could, even if it's just for limited use cases, you think?
Yes, it could change the state of play in the market because, one of the questions you asked, would we know a lot of the companies in the space? And you look at the list, especially the members of the Kinetic Edge Alliance, the answer is no. A lot of folks haven't heard of these companies. They're startups. They're well invested in. They're making a play into changing the market. And if architecture like Kinetic Edge holds up, they'll be able to collectively form a new market among themselves that even in limited spaces can go up against something like Azure or AWS. But then again, a company that's also very interested in what can you do in this edge space is Amazon. And don't think that they won't be investing in this too. Like taking some of their outpost concepts. Outposts you've seen in ZDNet are literally Amazon servers that are set up in customer premises or remote locations. There are pieces of the Amazon cloud that are already close to the customer. Well, they could conceivably build these outposts in places like this. They could station them around a city, and they could provide cloud computing services to a particular area. And that would mean that if you're in a major city like Indianapolis or Louisville, you wouldn't have to rely on a big hyperscale data provider that's in Chicago or Seattle or Houston or Reston, Virginia. You could have these closer encampments that are close to you. And Amazon has got the wherewithal to be able to invest in that sort of thing. So you could have disruption in the market, but that disruption could be taking place by the very people who are being disrupted.
A lot of moving parts here with this, Scott. We certainly appreciate your insight on this. And if you want to learn more about Scott's article, make sure you check that out on Edge Computing. It's on ZDNet. Thanks for watching.